Hello, this is Scott Dahman of PowerWorld Corporation.
In this section, we will introduce the auxiliary file format of PowerWorld Simulator, or the aux file format. And we'll introduce it first by talking primarily about the data section. PowerWorld Simulator data can be stored and edited in text file format. The aux file format is a text format that you can read and edit in a text editor such as Notepad. A scripting language is also available for modifying data and for executing commands, such as solving the power flow or running contingency analysis. The auxiliary file format accomplishes both functions. So data can be stored inside the auxiliary file and scripts can be run also. And when you load an auxiliary file, it will process both of them. The data that can be stored can be as simple as just a couple parameters for a single object, or even just one parameter, or it can be an entire power flow case and pretty much anything in between. The auxiliary file format also extends to one-line diagrams, so you can store a description of the objects that are on the one-line diagram, and then also load that back into a one-line diagram. This slide shows some of the practical applications for auxiliary files. One of the things you can do is standardize settings that you use in multiple cases and studies. So, for example, let's say you wanted to keep your simulator options the same in multiple files. You can just set them through the dialog in one file and then save that out to an auxiliary file and then load that into every other file that you need it. Similarly, you can customize your environment. So some of the settings in simulator options control the environment. Other things like display column options that you want for different displays in the Model Explorer, like the buses, generators, etc. You've got certain columns, certain number of decimal points in numeric fields, things like that. That can be saved out to an auxiliary file, and then you can standardize it across all your cases. If you have a procedure that you used to do some analysis, you can document and store all the steps from the base case until you get your results, and then be able to share that with a manager or a client. You can also, if you have detailed calculations and storing the results, something like contingency analysis or available transfer capability, ATC, you can put that procedure into an auxiliary file and then even have scripts in there that store the results out to files, and it can easily be applied across multiple cases then with just some minor changes. And you can also, with the AXD format, automate certain features on a one-line diagram. So this slide describes a procedure for using auxiliary files to customize a simulator environment. So there's also an option to automatically load a specified auxiliary file each time a case is loaded, or an option to load one each time any case is loaded. And we'll demonstrate that in just a moment. In this example, we're going to look at a series of files that set area zone owner filters, load some advanced filters and some custom expression, customize some of the data grids in the Model Explorer, and some other stuff as well. So we're going to use the case in the training cases folder called ActiveSG25K.pwb. It's a synthetic grid case that has 25,000 buses. So if I switch over to PowerWorld Simulator and I go to File, Open Case, and I locate the Training Cases directory, and then I scroll down and find ActiveSG25K, and we'll open that. And then next I'll go to open an auxiliary file, and there's several places that you can load them. You can right click inside the Model Explorer. There's also on the Tools ribbon. There's a scripting window right here that has a place that you can load it. I tend to use, in a lot of cases, the Load Auxiliary File icon on the Quick Access toolbar. So if we click that, and then we go inside the I04 subdirectory, and then this is the file I'm going to load. And what I'll do is I'll first open this with the text editor just to demonstrate what's in it. And we'll just associate it with Notepad. If you haven't done it already, then you can associate the aux extension with Notepad, which I find pretty handy. I hadn't done it yet on this computer. But inside the text editor, this is what it looks like. The two slashes are the comment string, which we'll get into a little bit later. And then there's a script section with a bunch of commands for loading other auxiliary files. So that's done here. And then each one of these files has other data in it. So for example, the 3010 filters and expressions, if we open that in a text editor, we can see it has some scripts, and then it also has some data sections. So we'll get to the particulars of the syntax in a moment, but just understand that for this example, we're just showing that when we load this, it's going to create a bunch of different object types that are going to be really useful. And if this was something that if these contain settings that you use all the time with all your cases, there's a way that you can have it automatically load, which we'll get to in just a moment. But I'll come back here and I'll load this master file right here that loads the other files. That's the aux 3000 one. And what I could also do, and I find this very helpful when I'm working with auxiliary files, is to load the message log and just make sure that there aren't any errors in the process. And it should tell you at the bottom that it finished loading the file. And each of the files that it called, it confirms that those loaded without errors too. We see that in the message log. So if I go to the Model Explorer, for example, and then open my advanced filters under case information and auxiliary here, or actually under conditions, filters, and expressions, and then advanced filters, I can see these are filters that were loaded from the auxiliary file. They weren't in the case before. Case info customizations, those are described in their own Model Explorer case info display. And so these were loaded as well. And if I go to the generator display, for example, I'll see it'll have some non-default files. It's got some frozen columns here. So all that was described in the auxiliary file. It's got certain sets of columns, certain fields that are shown. There's some custom expressions here for generator reserves. So that was all stored in the auxiliary file. And then if you want, if you go into the simulator options, and then you go under file management, there's an option to automatically load an auxiliary file anytime the present case is loaded. And you can just point to the file dialog right there, point to your file, or you can also automatically load a specific auxiliary file anytime any case is loaded. Similarly, point to it. And that way, if you've got settings that you want to use all the time, then you don't have to keep loading the file. But just be very careful with those features because you don't want to change things in the case that aren't appropriate for every case, especially with this option down here. So if we go to the next slide, it just shows that dialog and the options that you can use. And then this slide just shows how an auxiliary file can be laid out in two different types of sections. So the script section, again, has a starts with the name script. It can optionally be given a name, and that can be useful if when you load an auxiliary file, you want to just invoke scripts or data sections one at a time instead of loading the entire file. That's an option with the load script command, for example. And then inside curly braces, it'll have one or more script statements that'll just be executed in order. They'll always end with a semicolon. And then a data section normally leads with the name of an object type. It can optionally have a name, but if you automatically create a file, it's not going to have a name. You would give it one on the back end after you create the file. And then inside parentheses, a list of fields or variables that correspond with that object name. And then inside the curly braces, it'll have a list of the actual data that corresponds to those fields. And you can have one or more data sections and one or more script sections. If we go back to the filters and expressions that we opened earlier, then we can see some examples of this. Here's a script section. It does not have a name. Again, that's optional and only really needed if you want to just invoke a single section from within a file when you load it. It has some script actions that are set data is the name of the script action. And in the other section where we talk more about scripts, we'll talk about those commands and the references that you can use to figure out what commands to use for what actions and the syntax of those commands. So, but they always end in a semicolon if it's a script action. Again, here's a comment string that says that custom filters are going to follow, but that's ignored when it's processing the file. And then the object name here again is filter. And then these are the list of fields that are going to follow. And so this first filter has an object type of bus. It has a filter name of in service, Boolean logic of and then some other fields right here. And then the conditions are listed as subdata. We'll talk a little bit about subdata in a moment, but it applies to certain object types. And more in simulator, we've gone to where the subdata is optional in that it can be used in this format, or you can also specify the same information with multiple object types. In other words, you can have an object type for the filter itself, and then an object type for the filter condition, and then they can be loaded in sequence instead of being loaded. But the subdata is just it's properties of the main object that it is called underneath. So in this case, there is a single element to this filter which specifies that the status field of a bus equals connected. And if that is true, then the filter will meet the in-service filter. And if you switch back to the GUI and you look at the list of filters, you'll see that those characteristics match what was loaded from the auxiliary file. And if we go back to the next slide, it just describes some of the things that I just went through. The script section starts with the word script, has an optional name, then the actions themselves occur inside the curly braces, the statements end in a semicolon, and again, that's in a different section where we go into the details for that. And the next slide describes some properties of the data section. It's usually going to start with, again, an object type like we just explained. Name is optional, and then list of fields, and then the data occurs inside the curly braces. There is an older format that we have where the first string up here on this top line would be the word data. And that's a legacy format. And if you save data from the GUI using not the concise variable names, but rather where that option is unchecked, then it would use this legacy format. And I can do a demonstration of that in Simulator. So in Simulator, if I go to the case info toolbar up here at the top of the case information display in the Model Explorer, and I click options right here, you'll see in my setup right now, it's using the option for concise variable names and headers. And what that means, if I switch the headings up here from normal to variable names, then it's using the concise variable names, which are just easier to read. And as the name suggests, they're more concise. This is something that was introduced in sometime in the 2010s in Power World Simulator. And if we decheck that box, then we'll see it uses legacy names, which are a little bit, for custom variables, it's much less descriptive. For a lot of other things, it's just kind of longer and maybe has some text that's unnecessary. Like, for example, the megawatts, it says gen megawatt min, and the concise name, if I switch back to that, is much simpler. It's just megawatt min, because the gen is kind of redundant because we're in a generator object right now. So, but if I go back and decheck that, and then, for example, save this, we haven't talked about like creating an auxiliary file from the Model Explorer, but a way you can do that is from any display, you can right click in the display to bring up the local menu and then choose save as auxiliary file. And there's several related options in here. If you use the top one that's just auxiliary file, then it will save all of the records that are in the display. And it could be filtered too. It could be filtered with an advanced filter, but it's just whatever is presently in the display. It'll show all the records, and all of the fields will be written out to the auxiliary file. So if I go ahead and do that, and then I can just give it a name like temp generators. That lets me know in the name that it's temporary. It's something I want to go back and delete later, but I'll save that. And then if I open that in a text editor, then I'll see it uses this, what we call a legacy format. So instead of leading with the object type gen, it leads with the word data. And then inside the parentheses, the first text is the object type. So that's gen. And then there's a comma, and then the fields then occur inside these square braces. So Power World Simulator, when you load an auxiliary file, it'll accept either format, just either the current one with the concise variable names or the legacy one, which is more verbose. I would recommend using the concise variable names just because it's a little bit more human readable, but they're both correct. So if you have old files that use the old format, they're not broken, basically. You can continue to use them. So we'll close that. Okay, so again, back on the slide, that's described here that you can use either the legacy or the concise format. And the next slide just explains that you can, again, create an auxiliary file by saving data out from a case information display inside the Model Explorer. Earlier, I used the local menu by right-clicking on the grid. And it's worth noting here, we noted in other training sections too, especially the one on the case information displays in the Model Explorer, that the case info toolbar up at the top has essentially the same options that you get when you right click and bring up the local menu. They're just organized underneath buttons instead of in a bunch of nested menus. So the Save Auxiliary File toolbar button then has the options that you would get also when you right click. And we did the example of just saving the auxiliary file with the top option, which will store all the records and columns that are visible in that grid. Another option is to save just with the selected records. And what you can do there, if we go back to simulator here, I'll cancel out of this. You can make a multiple selection of different records by clicking and dragging, but the option will save all of the columns. So basically all of the variable names that are visible on the grid, this option right here, but only for the ones that you've selected. So here I've got rows 2 through 10 selected. And if I do that, another feature that's worth noting is when you go to save a file, if you pick a file that already exists, then you can hit save and it will give you the option to overwrite that file with just the new information that you're trying to write now, or you can append the new records to the bottom of the file. And so if I choose that, and then I go to open the file in a text editor, and I go to the bottom of this file, then I'll see that section that I just saved. And I'm back on the concise variable names right now, so it doesn't have the data word as the lead in this section. It just has the object identifier gen and then the fields. And so it has all of the fields, but just for the records that I had selected. And then finally, the third option in that group is to save just the selected records and columns. And so now if you make a rectangular selection, it'll only include what's in the selection. So it'll omit not only the other records, but also the other columns that aren't selected. So that's what that will do. And then going back to the slide, there's some related options where you can save stuff out in CSV format as well. And then also as graphics or as HTML code, and some options for GE PSLF file formats. So EPC is for power flow and DYD is for transient stability data. And another way you can add data to an auxiliary file is through most of the dialogues in Simulator. They'll have a save button at the bottom, and that's generally to save options that are present on that dialogue to an auxiliary file. So for example, this screenshot right here is in the contingency analysis dialog. And if you hit save on that, it will then bring up another dialog where you can choose exactly which options to save. So it's grayed out here that you're going to save the contingencies that are on the list. But that has to be checked if you're going to do the save option. But then you can also optionally save these other object types like contingency options, limit monitoring settings, etc. and then you can hit OK. And then there's an option to replace SUBDATA with data. We'll talk again on that a little bit more in a moment. But that's just for contingency analysis. And if we go back over to simulator, we can pull up any other dialog as well. Like, for example, the simulator options. There's a save to aux button down here. So if I wanted to save these options, each one of these checkboxes is basically a variable inside a object type. And if you mouse over most of the options inside a dialog in simulator, it'll give you a little mouse over hint that tells you what object type that belongs to. So this is sim solution options object type, and the variable name is check shunts. So that's the disable switch shunt, and that's a piece of data that would then get written. So if I do save to aux here, this is another one where you can choose exactly which types. So that dialog has lots of different pages and tabs that correspond to different options in option object types. And let's say I just wanted to save out the solution options. I could decheck all these others and then hit OK. And then I can give it a name. And then just go back and open the one I just created. I don't really need to do this. I'll hit cancel, but I'm just using this to access a Windows file dialog. So here's the options that got written out. And on some things, we've also got, it said in the dialog that the object type was sim solution options. So one way you could write that to an auxiliary file is with the object type sim solution options, and then you could have a whole long list of variables inside the parentheses, and then you'd have just a bunch of data on one line down here. That's a little bit difficult to read because you have to line up the variable name and match it to a piece of data underneath can be really challenging if it's a long list. So for things like that, we have an option to append underscore value to the object type. And now there's just two variables with each record that's underneath here. And the first variable is the name of the option, and then the next one is the value. So it's real easy to read it this way, and also to relate what you see here to what you see on the actual dialog that it came from. So yeah, that's how that works. And then on to the next slide. This just explains that if you pick an existing file, again, it'll give you this option. If you choose to override it, then it would delete, of course, whatever's already in that file and just replace it with the new data that you're writing out. But it's a good way if you want to put different types of data inside a single file to just progressively add more and more data to a file. So this next slide just shows some of the, I guess, more common object types that you might want to write stuff out to an auxiliary file for purposes of using later. It's by no means comprehensive. We'll come back in just a bit and show you how you can get a master list of all of the object types in simulator and then all of the associated data with it. But this is just an example of some object types that might occur in a data section. And then the next slide just describes the list of fields. Again, this is the stuff that occurs inside the parentheses. So all the fields that are going to follow. And this is where it describes if you want to get a master list of all the objects and all of the fields associated with those objects in simulator, you can go up here to, I got to back out of what I was doing earlier. Go to the window ribbon tab and then choose export case object field, and there's an option to send it to a text file or send it to Excel. When I'm viewing this, I usually like to send it to Excel because it gives you the option of searching the data by column. And also you don't have to give it a file name. It'll just invoke Excel and then put the data in there. So waiting for it here. It opened on my other window. So I'll move it over. So this is what it looks like. It gives you in column A all of the different object types just in alphabetical order. So the first one is 3-winding transformer, and then I can step down to the next one. There's a transient stability aerodynamic model for wind turbine blades. Is what that object type is. And so it tells you then all of the variable names, and it gives you kind of the legacy name and the concise name for each one. It tells you if it's a string or a real number. A real would be a floating point number, and an integer would just be an integer number. A description, and so forth. So some other things here. But what I also like about the Excel, the data being exported to Excel, is you can search. So let's say, for example, I wanted to find all the fields associated with a branch. I can just select field A and do Control F, type branch, and it'll just jump down there, and then I can see, all those. It might also be helpful to freeze the top column too. So you can do that on the, I can't remember where that is. I think it's on the window ribbon somewhere. But anyway, you can do that if you want to have that heading stay in there as you scroll down. Okay, and so the next slide just again says that the list of fields will be inside parentheses, or if it's a legacy format, it'll be inside square brackets that exist then inside the parentheses. It could take multiple lines of text. There's nothing wrong with that. If you go back in and edit the file after you've created it, then you can put a comment string if you want, and it'll always ignore everything to the right for the rest of that line until it gets to the next line that doesn't have a comment string on it. So also blank lines get ignored. The field names, the stuff inside the parentheses are separated by commas. Some field names have what we call a location integer. So we'll see this like on custom fields. If I go back to the one I created, earlier, I can open that, like the one for generators, for example, and I can see this is with the legacy format. So the 0 in the legacy format is just implied, but like the custom expressions that were on that data grid, the first one has a location integer of 0, which is omitted here. I think in the concise format, it would specifically put the 0, but then the next custom expression has a :1. And if you had like, even more of them on the display, they would get additional integers. So custom expression :2, :3, up to as many as you have. And another thing that's important, if you're writing data out for the purposes of being able to read it back in later, which is the main reason why you'd want to use auxiliary files, is so that you can apply it to a different case, or maybe apply it to that same case at a later time to reset things, maybe back to an original state. You just like when we send stuff out to Excel, that process we describe in the training section on the Model Explorer, you need to have the key fields present with your data so that when it's read back in, simulator knows which object each line of data belongs to. So for things that are like buses or things that are descend from buses, like loads and generators and transmission lines that have a from bus and a to bus, the key field is normally going to be the bus number. And then if it's one of those other objects that descends from buses, the bus number will be part of a multi-field key. So, like for example, with loads, you have the bus number and the load ID. With transmission lines, you have bus numbers on either end of the line and a circuit ID that make up the key field. Those key fields need to be present in what you send out. So the idea is that if you use the Model Explorer to send data out to an auxiliary file, that you make sure that those key fields are present. And then furthermore, if you want to be able to use the data section of an auxiliary file to create new objects, you want to make sure that the required fields are also present. And those are normally going to be shown. The key fields will have the yellow headings, but you might not know if all of the key fields are present. Normally with each of the displays, the key fields will be shown by default. But that doesn't mean, the display couldn't be altered to remove some of them. So of course, if you wanted to make sure that they were all on there, you could go in the Model Explorer to the list of fields, and there is a folder that shows the key fields and then another folder that shows the required fields. And normally the folder that says key fields is just going to show the primary key, which again is usually based on bus numbers. You can also have, for most object types, a secondary key field that uses the name and nominal KV of the bus in place of the bus number. That could also be used, but just with a note of caution that the name and nominal KV of the bus does not strictly have to be unique for each bus. You could have more than one bus that has the same name and nominal KV. And then you can also use labels as well as keys. So underneath the label field, there's a bunch of those. And depending on which one you want to show, the append label is if you want to type the name of a new label field, and then the ones that you would use as a key would be the one that says label for use in input from aux or from paste. So that you could use that, but it has to be populated. And normally when you're opening a new case from an industry source like a raw file or an EPC file, that would not be populated. It would, however, probably be populated in most CSV files that we can read in from EMS systems. So that's kind of a nice feature of those, is that they generally don't rely on bus numbers to be a key field, which is good because they're normally full topology models and the bus numbers are not consistent from one system topology to the next. So the next slide just describes some characteristics of secondary key fields. Again, it can be used if you have an auxiliary file that was created from an old case, and then you have a newer case where the bus numbers have changed. But just be aware that it's strictly a heuristic, because the secondary keys may not be unique, and then you're not going to have certainty as to whether or not the record gets brought in to the right object type. Or, I'm sorry, not object type. It would be brought in to the correct object type, because that would be identified in the top line of the data section. But there could be, for example, multiple buses that have the same secondary key, and then you wouldn't know which one gets the data that's associated with that inside the auxiliary file. And the next slide just describes kind of the use of labels that we looked at in the list of fields there. Again, the one that's the field that's called label for use in input from aux or paste would be the one that you would want to include But of course, you have to make sure that that gets populated first. And if it's a bus branch model in a raw or EPC format, then you probably first have to populate the label data before it can be used. But there could be some situations, again, like with EMS cases, where it's already populated and it may also be unique. So it can be a reliable key for associating data. And again, if you're using the auxiliary file to create new records and not just changed data for existing records, then you also need to make sure at a minimum that the required fields, and again, there's a folder for that, and those are the ones with the green headings in the user interface. So make sure those are included in your data. And then generally, you'll also, when you're reading it back in, if it's creating new records, you'll have to make sure that it's in edit mode so that it can add new records. And this slide just again shows the indications in the user interface of yellow for key fields, green for required fields. And if you want to make sure they're all on the display, then you can go to the list of fields or to the display column options and look at the folders that contain the key and the required fields and make sure all of them are shown in the grid. And the next slide just clarifies that with the legacy format, it's going to start with the word data. It'll have an optional data name, which again is most of the time you don't need to include that at all. But if you want to later use the load data script action to just grab that specific data section from another auxiliary file instead of the entire auxiliary file, then the data name can be used for that. And again, the list of fields inside the square braces, and then also file type specifier and create if not found are optional arguments that might occur. And the file type specifier for the legacy format would either be blank or the word or the string CSV. Blank means that the data that follow are space delimited, and CSV means the data that follow are comma delimited or comma separated values. And then the optional create if not found parameter would specify whether or not to create a new object in simulator if a record in the aux section that follows does not exist in the case. So it can either be yes, no, or you can just omit the field altogether. And if it's omitted, then the user would be prompted upon loading that field, do you want to add new objects? And there's also, I believe, a yes to all option. So you don't necessarily have to be prompted for every object, but you can also just specify the argument as yes, and then the user doesn't get prompted when you load it back in. And then again, the actual data occurs within the curly braces, and yeah, there's an open one and a closed one. And normally each object's worth of data would occur on its own line, but that's not necessarily required. Like you can have each object you could have a carriage return, and it could just to make it easier to read, I suppose. Although you can certainly do that in a text editor with word wrap as well. But if it does span another line, you know, simulator's just going to read the data in there as it corresponds to the list of fields. So if there's 10 fields, the first 10 pieces of data are going to belong to the first object in those 10 fields, and whether or not those 10 pieces of data exist on one line or multiple lines doesn't matter so much. It can span multiple lines, but each time you start with a new data object, that must be on its own line. So a single object can span multiple lines, but each new one must start on its own line. And then again, comment string is double slash. You can put that in the middle of a data line if you want, and then everything to the right of it will be ignored. Blank lines, again, are also ignored, and the curly braces must appear on their own lines, the open and the closed ones. And fields are normally space separated, but if the file type specifier is CSV, then it can be CSV. Strings are normally enclosed in double quotes. It's not required unless the string contains spaces or commas, because those could be misinterpreted as indicating the start of the next variable. So those should always be inside quotes. And this next slide just shows an example of a data section. We've kind of already looked at some examples by opening them up in a text editor. This doesn't look too much different, but it does show the options of using quotes or not using quotes with certain text fields. This is a bus name on the to bus name on a branch record. So branch is the object type. So it's a text field and it's got a space in it. So really this should be enclosed in quotes. And if you write it out from Simulator, from the Model Explorer, it's going to put the quotes in there. It's just kind of something to be aware of if you're using some other software to programmatically generate an auxiliary file that you then want to load into Simulator. This second line has an example where there's no quotes around the bus name. And that's also correct and would work in this case because the bus name doesn't have a space within the name. So the circuit ID then follows. That's got quotes because even though these all look like numbers, it's a text. It's a two-character text field, so that's in quotes. These other text fields are in quotes. Numbers are not in quotes, of course, and the spaces just delimit from one field to the next. And there can be multiple spaces too. It's not a requirement that there's just one space. So consecutive spaces would be interpreted as a single space. So if you had data that was just a blank string, then you would want that to be indicated with a pair of quotes that has nothing in it. Okay, the next slide introduces the concept of subdata, which we mentioned earlier when we were looking at our example file that had advanced filters in it. And for some object types, the data section doesn't define everything by itself. So you either need to have subdata or have the subdata expressed as a separate object type, which Simulator does do for, I think, most subdata. I don't know if it's completely comprehensive, but in the example we looked at earlier, of course, we had advanced filters and there was the object type would say filter and then list of fields. And the key fields were in there, such as like what object is being filtered by this filter. You know, it's a bus filter. So that would be like the first field. And then it had, 6 or 7 others. And then there were subdata underneath to list the conditions that are in the filter. So an advanced filter can have just a single condition, or it can have multiple conditions that have Boolean logic to combine them, like and or. And if you have a filter that has 3 different conditions that are ORed together, then you would have 3 different subdata lines to express each one of those conditions inside the filter. So another common object type that can use subdata is contingencies. So there can be some fields associated with each contingency, like the name of the contingency, whether it is to be run or skipped, etc. And then the individual actions that occur inside the contingency could be expressed as subdata. I know contingencies are one where it could also be expressed as 2 different object types. So there'd be an object type for contingencies and then one for contingency actions. And then by reading both of those in together, then you would get all of the information needed to describe the contingency. and the contingency action object would have as part of its key field the name of the contingency. So that's how each action gets associated with the correct contingency. In the case of using SUBDATA, it would be associated by the action under which the SUBDATA occurs. So the next slide just goes over some syntax. When SUBDATA does occur, it's got the little less than bracket and greater than bracket that enclose it. It's got the word SUBDATA and then the SUBDATA object type, name, and then the SUBDATA exists underneath that, and then it closes with this tag right here. And then also there's no list of fields that occur in the SUBDATA. It always has to follow a specific order. The best way to see what that order should be is just to send data out from the Model Explorer for an object that uses SUBDATA, and then go in and look and see what the format is. And then if you want to create something similar, you just have to follow the same format for the examples that you build. And it says here that there's more information in the online help. I find that the best reference for most things related to auxiliary files is the auxiliary file format PDF file. And you can get to that in Simulator if you go to Window, Auxiliary File Format. And then it'll open a PDF document like this that, among other things, it has a kind of a dictionary with syntax of all the script actions. Again, script actions are discussed primarily in a different training section. But if in this document, if I search for the word SUBDATA, let's see, there's a whole section in here on SUBDATA, and it's mentioned within individual items, but then it's also describes, there's a section that describes kind of all the SUBDATA if you keep going down right here. So yeah, it looks like on this edition that I'm working with right now, it's on page 162. And that could change in the future, but anyway, it just describes what it looks like inside a data section, and then it describes all the object types for which it may occur. Like, for example, ATC options with multiple scenarios. There can be SUBDATA for the different scenarios, and then it describes the format. There's a comment string in here that just basically explains that the first field is an index and then the next one is a name. So there's a reference for all the things in which SUBDATA may occur. But again, we've got, for a lot of SUBDATA, it can be described as just another object type. And I mentioned contingency analysis earlier. Let's just do a real simple example with that. So for that, I'm going to open the 7-bus case right now. So I'll go to File, Open Case, and then got to go to my training cases here, and then open B7 flat. And I'm not going to save anything there. And I'll just auto insert a set of contingencies, and I'm not going to get into the details of contingency analysis here. That's a separate training topic with its own slides and such. But if I go in here, I'm just going to auto insert some contingencies. And then what I'll next do is choose the save option right here to write the contingencies out. And I'll just give it a name, B7 flat CTG. And There is, on this particular dialog, there is an option to replace the subdata with data. And it says that that's recommended. Recommended, I think, just because it's a little bit easier to read. But yeah, we'll go ahead and leave that checked. I'm going to clear the options and all this other stuff just to make the resulting file a little bit easier to navigate and so forth. So we're going to save the contingency definitions and we're going to replace subdata with data. And what that means is that for each contingency record, instead of seeing a subdata line that has the action associated with that contingency, it's going to write the actions out as a separate object type. So I'll go back now and open the file I just created in a text editor. And I can see here there's a data section for the contingencies, and it's got the name of the contingency and other fields that are in that list that are associated with the contingency, each contingency itself. And then there's a separate object type called contingency element. And this has, as part of its key field, it has the name of the contingency and then a string to identify the object. So because I just auto-inserted single action contingencies, I have 11 contingencies and 11 actions. And each one of the actions corresponds to a contingency. But if you had contingencies that have multiple actions, you would just see that key field repeated with a unique, that the second field that's in the key, the object identifier, would be different for each line. So there's just different ways to write that. And if I did the same thing with subdata, it would look a little bit different. So let's do that example now, where I write this out and I don't use a second data section, but it will use subdata this time. And I'll just overwrite that and then look at it in the text editor. Now, oops, I've got some other objects that I didn't tell it to omit. But if I scroll down to where the actual contingencies exist, I can see the contingency records. That data is the same as it was in the previous example, but now instead of having a contingency element object, it puts the contingencies elements in as subdata. So they're both correct. You just might prefer the way one of them reads or the other one reads. So just know that that option is there from a lot of the menus that will write out data sections for the object types that have subdata. Okay, and then going back to the slides, the next few slides show this is not a comprehensive list. I would say use that PDF file that I just mentioned to look at a full list, but like contingencies is one object that has some types of subdata, and these are the different types of subdata. So the contingency element is the one we just looked at. If you've already run the contingencies and you have results, then the violations could appear as subdata. And then also if you have solution options that are associated with individual contingencies, those could appear as subdata as well. So the contingency options themselves, advanced filters, that was the kind of the first example we looked at. The conditions underneath those filters can be subdata. Generators can have bid curves and reactive capability curves. I know those can also be expressed as their own object type instead of subdata, in which case the generator's key fields would be part of the key fields when this is expressed as data and not as subdata. So I think there's a couple pages of this, but again, it's not necessarily comprehensive. You refer to the reference document PDF for a full list. But yeah, this just says that there are many more. And yeah, we looked at this already in the notepad, but here's an example here where here's a contingency that's got several different actions. So they're all listed underneath in between the start and the end identifiers for the subdata. And then the next line after the ending identifier for subdata is actually the next contingency record. So, and then this contingency has just one action. This one's got several. So they just occur underneath or in between the subdata identifiers. And this just relates, what's in the auxiliary file to what's in the case info display. If you start from the case info display as we did earlier and you write out an auxiliary file, you should be able to kind of match up the data that you see in one to the other. So here's the list of megavar fields right there for all of the generators, and here's all the generators in the list that correspond. Okay, we mentioned earlier that you can view variable names in the case info, and I demonstrated it earlier using the case info toolbar. So again, if we come back to simulator, you can go under options and then change the headings. The normal headings are the ones that are easier to read, and of course the variable names are what would actually occur then inside a data section of an auxiliary file. That slide just shows that you can also go all the way into simulator options, and underneath case information displays, you can do other things like change colors, and then there's the column heading options right there, normal or variable names. Again, if you just want to change that, it's probably easier to use and quicker to use the case info toolbar than it is to come into this menu, but it's the same piece of information that you see there. So, looking at variable names, they're a little bit harder to read, but if you need to relate exactly what you see in the user interface to what you see in an auxiliary file, then you want to use variable names. And you can switch back to normal for, all other purposes generally, because it's a little easier to read. And then back in the dialog, there's also the checkbox. This should actually point to about here. There's a checkbox for using the concise variable names. And of course, in the case info toolbar that we looked at earlier, that is also a checkbox under that same drop down. And the next slide just shows that. Again, this is what we did earlier, is we used the option drop down, change the heading type, and then also use concise, or if it's dechecked, it'll use the legacy variable names. And the next slide just has some screenshots, kind of placed together for reference. This is normal headings up here. This is variable names right here. It looks like this is the concise variable names, and then this is the auxiliary file that has concise variable names. So those match. This is the same field, just normal versus variable name. The concept of the auxiliary file is also extended to one-line diagrams. So that is called a display auxiliary file, and it has the extension AXD instead of AUX. But the syntax is very similar. It's just instead of referring to power system model objects, it refers to one-line diagram objects. So one way we can see what this looks like is from a case with a one-line diagram open, we can save the one line to a display auxiliary file. And we can also look at what's called the display explorer. So we'll explore all of that next. If I go back to my 7-bus case and I make the one-line diagram active, I can go to File, Save One Line As, and then for the type down here, the default is going to be PWD. That's the binary format, but we can also choose Display Auxiliary File, and we can call it b7flat.axt. So we'll save that. And then you can also load display auxiliary files from the local menu if you right-click on the background of a one-line diagram. I'm just going to use that option for the simple purpose of accessing the Windows file dialog. And then I haven't yet on this machine associated the AXD with Notepad, but I could choose to do that right now by saying open with, and we'll find the Notepad app, and then I'll just leave this box checked so that Windows will know that the AXD can be opened in Notepad. So it looks just like a bunch of data sections in an aux file, except for the object types all refer to one-line diagram object types. So you can use this format to modify, parameters of objects on the one lines, or even add them entirely. So that's the entire display. It's not too big of a file because it's not too large of a one-line diagram, but there's also a model explorer for the objects on the one line. And if I go to the one lines ribbon tab and then list display and then choose all display objects, it'll open that. We call it the display explorer, and it looks kind of like the model explorer in that it's got case info displays over here and then objects in different menus over here. So all objects shows everything with the type of object. If I just want to look at bus objects, I can go under network buses. And generally for things in the display explorer, the key field is going to be the underlying objects key field. So in this case for buses, it'll be the number. And then a second field will be appended to the key called auxiliary ID. And that's for the purpose that on a one-line diagram, you could have the same object occur twice in two different places with different properties if you wanted to. It would be kind of unusual, but there's certainly no rule against it. So if bus 2 occurred a second time, it would just have a unique auxiliary ID that would describe the second instance. But like for example, it's got the screen position, and just like in the model explorer, we can switch between normal headings and variable names, and it's the variable names that would be used in the AXD file. The object name in this case is display bus, and then these are the variable names, and I think these are the concise ones. Yes, they are, because this box is checked right here. So, and just like with the Model Explorer, you can right-click and then save the things that you see here as a display auxiliary file. So back to the slide, this just, again, on this last bullet point, it clarifies that the auxiliary ID is used as an extra key field for objects to identify the representation on the one-line diagram. And then, again, this is the Display Explorer and the list for all objects. It's going to have kind of some generic fields that apply to all objects. So, the screen layer and stuff like that is shown in there. And you can edit those parameters in the Display Explorer, just like you could edit object parameters in the Model Explorer. The blue fields are ones that you can just type in a value. There might be some toggleable fields that show up as green and so forth, just like they do in the Model Explorer. And then there's a button down here where you can save everything to an AXD if you want, not just what's on the current tab that's shown. And then here's an example of display buses. Again, we just looked at an entire file for the 7 bus case. This is an excerpt of that just shows the 7 buses. So there's a bus number, an auxiliary ID, the position in XY coordinates, the thickness of the bus object, what color it is, the 0, I believe, corresponds to the black, and so forth. So other properties of the object on the one-line diagram. here's an example where we can use the AXD on a one-line diagram that already exists and add some modifications to certain objects. So this is an excerpt for this file, and I'll next go ahead and load it. But it refers to a display transmission line object. And again, it's got the key fields that you would expect for a transmission line, the from bus to bus and the circuit ID, along with the auxiliary ID to identify it, which again, if the object only occurs once, it's normally going to have an auxiliary ID of 1. And then there's some subdata which show the vertices of where that line's drawn. So this could be used to change the routing of a transmission line, and say that the coordinates might be locations of towers. So you can represent the routing on a geographic one-line diagram in a way that reflects how the line is actually routed. So switching back to simulator, I'll open the case and the one-line diagram that are used in the example. So open case, and in the training cases, I want to find the raw file called active sg10k opf.raw. So it's this one right here. I think this will also work if you open the PWB of the same name or similar name. We won't save that. And because it's a raw file, it doesn't have a one-line diagram associated with it. We'll have to open the one-line diagram next. So once the case opens, I can go to File, Open One Line. And in the training cases directory, I'll grab the one that's called ActiveSG10k.pwb. And this example will also work on a blank one line. It'll just add the objects that are in the display auxiliary file to a blank one line. And I know we can open up the display auxiliary file and look at the contents, but I know this example does some modifications of transmission lines in here. Don't mind the question marks in this example. It's because this is a raw file and these correspond to substations, which don't exist in the raw file, but the transmission lines do. So that's why they're shown with the parameters from the power flow case, like the flows and the loading percentages. But if I right click in here and go to load display auxiliary file, and then go into the I4 subdirectory of training cases, I'll first open this in a text editor. It's got a background line for the state of Washington with coordinates, and then later on it modifies some transmission line parameters. So between certain pairs of buses, circuit ID, and auxiliary ID. So we'll see, if we go ahead and load this, we'll see that some transmission lines in this area, the routings will be modified by that file. So I'll click open. And yeah, we can see right here it added some vertices. So it loads that information in. And again, if you had a blank one line, you could go to File, New One Line, and then load the same auxiliary file in, and it'll set the map projection and then add those objects. I might have to zoom to the proper location. I can do that on the One Lines ribbon by choosing Show Full, and I can see these are the objects that were added. Again, that's just some ways that the information from one-line objects can be stored in a text file, and then that can be used to create or modify an existing one-line diagram. All right, the next subtopic that we'll talk about here is the auxiliary file export format description. And this is a tool that allows you to define a preset list of objects and data sections, optionally with filters associated with objects, where you can basically dump out an auxiliary file with all of that data for the current case that meet the description. And once you have one of these, you can use them with multiple cases. An application would be like if you always want to store, like say, some generator parameters from a case out, and then you want to go to another case and then store the same parameters for that case into a different auxiliary file. It's just a quick way to dump everything out without having to manually configure your individual Model Explorer displays and or go into individual dialogues that have the option, to save those options out to an auxiliary file. You can just define everything that you want to save once and then use that to save things out as many times as you need to. So if we switch over to Simulator, we'll find that tool on the case information ribbon and then aux export format description. And you can create your own by clicking the new button and then giving it a name. So we'll just call it something like aux file set 1. And then down here, you can insert whatever object types you want and then whatever fields you want. So insert object type here. I can choose, for example, buses. That would be under network, and then bus. And then you can optionally apply a filter. So if you had filters defined, you can pick them from here. If it's an advanced filter, you can just say use the area zone filters or use the objects whose selected field is set to yes. And there's a way you can go out and then set the selected fields for certain objects just by double clicking on that to toggle it if you need to. Let's say we wanted to use the area zone filters, we could do that. You can bounce out to the area zone filters and set those. So let's say we wanted to toggle everything to no except for Washington. We can flip that back to yes and then click OK. So it'll save buses. And then over here, you choose what fields and then optionally what subdata for objects that have subdata to include. So I can click modify and then add certain bus fields. This can be kind of tedious, I guess, to set up the first time you do it, but once you set it up, then it's done. So for numeric fields, let's say we wanted to put the name of the bus and the number of the bus. We can make multiple selections too and add those. We could put the nominal kV, that would be under voltage here. So kV nominal, add that. For numeric fields, you can tell it how many digits and decimal places to include. That'll be part of the specification. And then you can click, you can click OK. That'll close the dialog. Let me go back to the dialog. I didn't mean to do that. Once you set everything up, then you can also say create an aux file with the specified formats. And then I can give it a name, temp buses or something like that. And then I can open that in a text editor. And I can see it's got all the fields that I specified for buses in the kind of haphazard order, I guess, that I specified them. And they're only the ones that meet the area zone filter of area equals Washington. So it's not all 10,000 buses in the case. It's just creating an auxiliary file with that specification. And of course, you're not restricted to one object type, you can keep, inserting new objects as you need to, and then add fields and so forth. Once you create this description, you can also save it to an auxiliary file, and that way you can use it in multiple cases and so forth. So that's up here. And then we also have some presets that are underneath create format for complete case. So you can pick certain things that you want to include. So like the network model would be kind of a common one. That would be things like buses and generators and loads and transmission lines and stuff like that. You can say, let's include that. To keep it simple, I'll just leave that, but you could check some of these other boxes if you want. And then you can click OK, and then it's going to give you, based on that preset, that network model preset, or it's going to give you a bunch of object types, and for each object type, a series of fields over here. So this is for substations. It's got number, name, sub ID, latitude, longitude, and so forth. So if I wanted to send this out to an auxiliary file, I could go out and give it a name, temp, say network model. And then if we look at that, it's going to have data sections. Oh, it's still writing. Okay. It'll have data sections, 49 different data sections here. If we go out to that, it's quite large. In this case, about 9 megabytes. But if I open it in a text editor, then I can see, all the objects that are specified there. So you could take one of the preset ones and you could edit it. You can change the order that things appear inside the file, move up, move down to do things. You could pick a specific line item and delete it. So you create your own or start from one of the presets up here, and then optionally modify the preset if you need to. So this next slide just shows some of the features of that dialog. And again, you access it from the case information ribbon tab. And then the last few slides just go through some other topics. They're denoted with a red dot, meaning I'm not going to go through them in detail, but they're just included here for reference. So this talks about some different objects that, for example, have, instead of subdata, they can be accessed with separate object types. And there's some advantages to doing that. I think sometimes the subdata might actually be easier to read if you're reviewing a text file, but there is some limitations to it. Like subdata can't easily be copied and pasted from a spreadsheet, for example. Using script commands like save data and set data. Again, script commands are talked about in another section, but those are things that you might use either in an aux file or in conjunction with SIMAuto. And it's hard to manipulate subdata that way, or hard or impossible in some cases. So having a separate object type for things that can also occur in subdata, sometimes a separate object type is easier to work with. So the next few slides just talked about some examples of that, like reactive capability curves, for example. There's an object type for that. It can also be a subdata type of generators. So that's described in the documentation, but these slides are included here for your reference. And here's an example of interface with elements that occur within interfaces. So this is the subdata method, and this is the separate object type with interfaces and interface elements. Again, I think this is kind of easier to read, but this is definitely better for use with SIMAuto and things like that. So, but it's the same data, and other examples that are shown in the slides.
If you need further assistance, please feel free to look us up on the web, give us a call, send email to our support line, or if you prefer to work with a particular Power World engineer, please feel free to contact that person directly.